Okay, good afternoon, everybody. My name is Kieran Walsh, and I am the Director of Applications Engineering for a company called Audinate. We make a technical solution called Dante, which exists to put audio and media onto standard IT networks. So today I'm going to talk to you about my personal experience in deploying audio over IP in a live sound environment. My background is somewhat varied. I was originally a musician, and then I worked in live sound for a long time for a big concert production company in England. So we used to do presentations a bit like this. Now, I've included this video from a show that we did before we were using audio over IP, just so we can show what we have changed in terms of production design. So this was a big concert that was done in 2005 in London. We had, I think, 38 international artists. We had an audience somewhere between 300,000 and 400,000 people. And the things to watch out for on the video are, look how big the speakers are, look how visible they are, because this all changed. When we started to be able to use audio over IP, all of this stuff became better looking and easier to deal with.
Music makes the people come together. Music makes the bourgeoisie and the rebel. Music makes the people come together. Music makes the bourgeoisie and the rebel.
So we had to deploy many speakers in the audience. We had to put 10 positions. Each of those probably consumed somewhere between 30 and 50 kilowatts per tower. And of course, this was before we had audio transport over the network. So we were using old-fashioned copper lines. And this meant that we had to put real people at every speaker position to monitor the audio and to ensure that nothing went wrong, because we had no way of telling that remote systems were switched on. So it was good. It provided a lot of jobs. We had 30 people sitting in the field in the sunshine. Well, England, not quite sunshine. And yes, it was a good day out for everybody. So we had remote control systems. The first thing we did was look at how we could get the control working on a network. This would help us to reduce the amount of cabling we had, and also how many people we had to deploy to make these things successful. So my first experience of Dante, this audio over IP method, was with a product called the Dolby Lake processor, which was released in 2006. And originally, I had 16 of these to do this world tour with the English artist Robbie Williams. And in 2006, this solved the problem of us being able to remote control these system processors. For this tour, we had 14 towers in the audience, and we had a very complex array of subs around this part of the stage, and then quite a complex set of fills, because the artist would come and sit on the speakers at the front, put his microphone in the speakers, so we had to have individual control of every single cluster, because anybody who works in live sound knows what happens when you put a speaker and a microphone together, especially on a system that big. It's not nice. So after a couple of years, after 2 years of using the Dolby Lake processor for system control, there was a firmware update, and this thing called Dante was made available to us. So, to be perfectly honest, my first reason for using Dante was it was free. I put some new software into these already quite expensive processors, and then I could move audio around. So we thought that this was a good idea. It was one of our strategic aims at Britannia Row to look at how to start moving audio over a network. It was obvious in 2008 that that was where the world was going to go. So we started with this system because it was free. And like all things, you only learn about a technology by using it. So the first time I used Dante was almost exactly 10 years ago now. And this was for a television production with the UK military. So we had tanks and aeroplanes and all kinds of things going on around St Paul's Cathedral in London. And we had to have loudspeaker clusters all around in the city, all controlled from the same place. Now, I'm not sure whether I was being told the truth, but we were told for this that we could not put cabling on the ground because horses don't like cables. I don't know whether that's true, but the guy telling me had a gun and I didn't. So I thought best not argue. So we had our control and audio combined onto one cable. Now, that's really the main reason why we use audio over IP at all. I am not a believer in technology for technology's sake. I think something has to be useful. So the technical reason for having anything over an IP system is that you can put different kinds of traffic onto the same cabling infrastructure safely and have them come off the other end without being destroyed. That's the only technical reason for using IP, really. And then the second reason for using IP is financial, which is that you can save lots of money by only buying one cable infrastructure. I think they're two pretty good reasons, but if anybody tries to give you other reasons for using a new technology, yeah, they have a good imagination. Those two reasons are the reasons for doing it. And that worked very, very well for us. It covered what we needed to do, and it saved us a lot of money, and most importantly, it saved us a lot of time. So, of course, then, a few weeks after that, in May, we thought we'd deal with this one, a small event that happened over here. So, at the end of the Olympics in 2008, during the closing ceremony, there was a section from London outside Buckingham Palace. So we deployed an audio over IP system, again on Dante, using the Dolby Lake processors, to do the London cutaway section. And this time we were looking at what different choices were possible from a technology perspective. So we had the Dante system running, and then I also had two other technologies put side by side on this project, because, like I said, the only way you can tell if something is good is to compare it and really use it. So one of the technologies we used was a non-IP system called CobraNet, which some of you guys may be familiar with. I used to do corporate installations before I went into large-scale events, and we used to use CobraNet a lot for corporate boardrooms back at the end of the 1990s, early 2000s. CobraNet stopped development in the early 2000s, but we thought we would have to compare what was already in existence with Dante to have a look. And there were some very slight sonic differences that we could hear, but nothing massively significant. The really big difference was how much easier it was to deploy the Dante system. It was just plug and play. That's mainly because the amount of work that has gone on in artificial intelligence, just in the world in general, has been huge in that time period. It's now something that is expected of all technologies. So it's only right that an audio system should follow the same path. So this was the cutaway section from Beijing. Notice still we're still using very large loudspeaker arrays. You can just about see them here. So we were still using a very, very conventional system. We hadn't quite got completely to grips with what we could do with such an amount of processing power and distribution. And of course, even though these are, by live concert terms, small system hangs, they're still very visible on television, and after all, this is a television production. It's difficult to get the control for the audience with such a small array. So you're in this compromised situation the whole time where you're trying to give a good audience experience, but your primary responsibility is for the television production and keeping it visually nice. So it's something that we improved upon over the coming years. So we had a smaller audience this time, about 100,000 around Buckingham Palace, a very large live-to-air TV production, and of course we had to just basically deal with this conventional system, like I said, because we're still learning. So why was this approach successful in the end? Well, the key thing for deploying audio over IP and live sound was that with rental companies in the events and rock and roll markets, we service customers who work for the bands. So the mixing console, the effects units, the microphones, those are all fixed requirements, and as a rental company you cannot dictate to your clients what they will take. So the only thing that the rental company really has control over is signal distribution to the PA system. So the client will also specify normally which loudspeakers they want, and you supply those, and then they don't really have much concern about the cabling. As long as it works, they're quite happy. So that's the only place really where a big rental house has control. So having the Lake processor and initially deploying audio over IP into the distribution arena after the mixing console was exactly the right sensible place to start with audio over IP, because trying to get it into a mixing console is challenging, because then you have to promote a completely new mixing console to the band's engineers. That takes time. And if you put it directly into the loudspeakers, again you have to create new loudspeakers. So having this thing that could be dropped in seamlessly and could be quietly migrated to was really quite a successful thing. And it's really only in live sound that can be done quickly, because if you're in a fixed installation environment, that installation has to have a certain lifespan. It has to be around for several years. If you're in broadcast, again, you're putting in a system that's a solution for the next 20, 30 years. It has to be absolutely tried and tested. People are quite conservative. In a live sound system company, your return on investment is measured in weeks, not years. So you can be more adventurous with these things. You can run it as a parallel solution, see what works, and then optimize that out. And yes, we went through many, many different iterations of how to make this work. It took probably 2 years to work out how to package an audio over IP distribution system that could be understood by all of the technicians. Because there's no point getting a great technology that only 4 people can understand. You have to make sure that all 500 of your technicians are happy with it. And working out how to do that training takes a long time. And of course, all we wanted in live sound was reliability. And if we could get cost effectiveness for it, okay, that was nice. Now, what we found with the cost effectiveness side was that the ideal medium for moving this data around a live sound site is actually military grade fiber optic cable. And what we found was that we were paying a lot of money in the audio business for this cable. So we went to a military supplier and bought it direct from them, and we saved about 70-80% on what we were being charged in audio. That's slightly changed now, but it was a significant factor when we first looked at it. And again, this wasn't unusual. If we go back to the 1970s, the company I worked for used military components for making multi-core cables, because multi-core connectors did not exist in 1974. So there was a military shop next to their workshop where they sent old electronic parts, and my colleague found the data connectors for tanks. And they're really good. They're very, very tough, they're robust, and as military surplus, they're very, very cheap. The problem was, when he went to buy the second set new, he found out how much they really cost. Because, no, they're very good, but they're not cheap. So with the fibre optic, we took a similar approach and did a similar purchasing pattern and were very successful. It's incredibly strong stuff. So the next big milestone for us was to make sure that we could then, instead of deploying with specialist technical crew for television broadcasts and things in a London-centric environment where it was easy to support it, the next milestone was to put it onto a proper long-haul tour. And the first tour we used audio over IP on was on the Oasis World Tour in 2009. This is a photograph of Slane Castle in Ireland. Absolutely huge. Again, quite a traditional front end. You can see here that we had an analog system for the band to the front of house position. So we had a normal stage box and a normal Midas XL4. For the band, we took analog into the processor, and then we distributed around the site over audio over IP. And this also allowed us to monitor the amplifiers and also find out the status of everything, which was very useful when the power fails, because you can find out which generator has gone wrong and talk to the generator man rather than trying to find it yourself. So this was the key thing. Up until this point, we were taking a digital system and we were just replacing what we were doing with an analog system. So our benefit was we could reduce the cable weight. The costs were beginning to pay for themselves after this migration. Like I said, your return on investment in a rental situation is weeks or months, not years. So it was paying for itself nicely. But we hadn't really explored what we could do with the greater control, because now we were dealing with a system that could do hundreds of channels, not just tens. So we could build very, very big distributed systems with very small loudspeakers, and we could make very loud but invisible sound systems. I remember a friend of mine who sadly is no longer with us. We worked on a show in 2012 together, and his comment upon talking about the design was, "We've gone past the point where we're just trying to copy analog." They were his words, not mine. And his point was, it was now taking longer to try and duplicate what we wanted to do with our designs with no restrictions, trying to put analog in, and it was causing more trouble than just going straight onto the data network. So around about 2012, we completely ditched using analog as a backup. It just became too complicated. Which sounds like a strange thing to say. Everybody says digital's complicated, so why am I saying analog is complicated? But at that scale, it gets very complicated indeed. So, in 2009, we had Oasis safely on the road touring. Apart from the humour of the band, that was okay. And then we got asked to do a piece of consultancy for a large music festival. So this was in London, and we were given a requirement that we were not allowed to exceed 85 decibels without an A weighting. This was linear, only 80 meters from the main stage, which is impossible. It's absolutely crazy. The sound of the buses going past, because there was a road between the measurement point and the stage, and a busy road with lots of buses. Buses are louder than this. So it was virtually impossible to measure what we were doing compared with the traffic. But anyway, they had their lawyers on us. We had to look like we were doing it. So we needed to monitor all of the audio from all of the 4 stages that we had. And we needed to take action if there was a breach of this noise limit. And of course, we had the issue of security. Not about people coming in and hacking the system and doing bad things. But when you connect 4 stages together with 4 sets of technicians, with 4 sets of computers that can control the system, the chances of somebody accidentally making the wrong change to the wrong device is very high. So luckily, with a little bit of judicious hacking, I found out what control ports were being used in the IP data, and basically just stopped the control leaving the stage. So the only devices that could be seen on each stage were the right devices for that stage. However, the audio could leave the stage quite happily, and we could distribute the audio however we saw fit, which meant that the technicians could keep managing the stages properly and without any worry that they would be touching the wrong thing, and we could continue to manage the audio all on the same cable, using something very much like an IT management technique. So this is a very simple drawing of it. We had this command and control cabin in the center. We picked up all of the audio from all of the stages, and we processed it and sent it back to the system. So if we saw too much 200 hertz on one stage, we could turn that down, send it back within a few hundred microseconds, and it would rejoin, and we'd actually have an effective filter to stop off-site noise pollution. So like I said, we just filtered the IP port addresses, just like any other network service, and we wrote firewall rules into our distribution system to make sure that we didn't join the stages up together on the control system. The following year we improved upon this again. This is always an experimental thing, and we used the virtual sound card with the smart software to do the analysis of each stage. So we were able to take coherence measurements from each stage to work out which was the major contributing factor at our measurement points by checking the coherence and delay between a stage and what was being measured. So again, a massive improvement there. So the key thing about networking is a network is only as good as the number of different things you can plug together on it. After all, when we use something like WeChat, we're connecting to hundreds of millions of other people. If it was 2 other people, well, you would just use the telephone. So a network is about the sheer size of the number of users it has. And of course, in order to get users, you need products. So this is how we've grown audio over IP in Dante since I started with the company in 2010 till about 2 years ago, and we've seen this rather good growth rate. So to conclude, this is the concert where we worked on this, trying to get an invisible sound system. Now again, we have an arena here, but it's very difficult to see any loudspeakers. They are there. They're very, very, very small, but they're virtually invisible. I have a clip of this just to show the size of it, because this is only the small end. This stretches right down. And just so you get an idea of how long the street is, remember that the video screens are delayed to the audio. So we wanted to maintain lip sync all the way down the street. So when you see the shot with the multiple video screens, notice how long it is between the shots changing on the video screens, and that shows you how long the audio is taking to move. It's seconds. See these screens changing at different times. So yeah, we had had nearly 1 million people in that audience. And that was just all on a tiny piece of fibre. Some of the other challenges with that project, the stage was in the middle of a roundabout, so there were cars going past while we were setting up. They didn't allow us to connect the cabling until 3 hours before the show started, because we had to stop the traffic. So really the only practical way of testing the system was to use a digital system, test one side, then plug in with a sound card, test the other side, and then hopefully 3 hours before the show, plug in 4 pieces of fibre optic and hope it all came up, which it did. There were some other cool things. I mean, from a digital perspective in general, there was one number where they had a symphony orchestra in the middle of the roundabout, and they were trying to remove a rock band while this orchestra was playing, and they had 2 singers on top of the palace, so 200 meters away. And of course, somebody sensibly said, well, if you're going to remove risers and drum kits and stuff, it makes a lot of noise. Certainly a lot of noise when you've got some string players playing. So the night before, we recorded the orchestra in the middle of the roundabout live, and then used a playback. So it was, the first 3 minutes was just stuff being played back off a multi-track, and we told the cameras to stay away from the stage and focus on other things. Got the band off and then cross-faded the entire thing across to live just for the end, so it looked real on television. And that's just cool. These are the kind of things that using computers and digital capture just really, really help with to make even better productions. So yeah, that's a brief story about audio over IP in live production. Are there any questions? No? Okay. Oh, you have some. Cool.
No, I will translate the
Okay.
Chinese questions.
Okay, yeah. Oh, okay. No? Okay. Oh, lovely. Oh, sorry. Yeah.
哎，老师好，那个我问一下，就是我们在做现场在那个大型演出的时候啊，很多这个现场的直播和我们后期制作是不同步的，特别是视频和音频流的传输，它是没办法进行一个同步性。那我们这块是怎么解决的？那这个单听的技术和模拟的技术是怎么进行一个很好的融合的？啊，想了解一下这方面的技术。
We were doing some live shows. Sometimes the audio and video don't sync together.
Okay.
Yes, and how do we use Dante and the analog system to solve those kind of problems?
Okay, so was it uncompressed video that you were using?
Live broadcast.
Yeah, but it depends on the format of the video.
Yeah.
So was it SDI video?
您的那个视频是什么类型的？是 SDI 吗？我知道是现场直播，他就说那个是 SDI。Yeah, SDI.
Okay, so you can synchronize your black and burst on the SDI to audio word clock, and Dante devices can receive a external master clock from your black and burst and synchronize that. That will keep everything locked together.
那个我们这个设备是因为我刚过来哈，这个设备是自带时钟和时钟，因为是同步的嘛。这个时钟，这个时钟的话，是在我们的芯片里边，还是说我们需要单独配？它是在这个设备里边吗？
I want to ask, is the clock inside of the device, or should we buy a clock somewhere else?
Okay, so Dante distributes all modern audio over IP and also video over IP systems. They distribute time rather than clocking. So there is a media clock inside every single device, and time is shared between them. And that time is resolved down into a media clock appropriate for the audio or the video. So if you look at, on the video side, SMPTE 2059, which is the video synchronization standard, that explains how precision timing protocol, which Dante also uses, functions to synchronize that. In terms of synchronizing SDI, which has a real edge clock, then you might want to find a device that can resolve black and burst to audio word clock, so something like the Apogee Big Ben, and then feed that audio word clock into a Dante device, which can then become the master for the Dante network. So it depends on your video format. So with older SDI, yes, you would look at something that could convert video clock to audio clock as normal. For newer SMPTE-based video over IP systems, there is a lot less need. Okay.
Can I have the question in English?
Yeah, sure.
Thank you. So, for new users of this Dante system, can you summarize in very short words about which place should we put the focus in? Like the advantage of the system when we do the deployment of the system. Like which place should we put our main focus in? Because there should be a lot to talk about for this Dante system. Is it syncing, timing, and system configuration? Can you give some very, very short words, and we can do some homework at
Sure.
at
So it really depends on which business. Are you in the events business? You're in the live sound business. Okay, so that breaks down into different sections. So there was, like, where I was working with these style of bands, where I could not say which mixing console my client was taking because they're the boss. There are other things where in more corporate environments, I can, as the rental company, say, you are taking, say, this Yamaha desk, or you're taking this Digico desk. And sometimes you're allowed to do that. And that is much easier because you can have a much more overall control. So my experience was I had to alter things where I could, which was only in the signal distribution system. And the advantages there was that I could send any signal to anywhere I wanted. So it was very, very flexible. When I plug stuff in, it just appears. I don't need to configure it. So very, very fast, which is true of all aspects. But in a signal distribution system where I am sending a small number of signals to a large number of destinations, an IP system is brilliant at doing that. It's very, very quick to configure, very fast, and everything is perfectly synchronized. So everything is within 1 microsecond of anything else in the network.
Oh, actually, that means you can bring your own custom gears, and you can send them with just this format, and let them be usable for the system instantly.
Yeah. So it plugs in, it pops up, and you just route the audio. Yeah. Sure.
哎，你好，我听到过有一种说法，就是在单听使用超6类以上的线的时候，会出现一定的兼容性的问题。但是呢，我没有找到具体的那篇文章。我是曾经听说过有朋友跟我介绍过这样的情况。那么我想问一下，它单听在超6类或者是7类甚至7类以上的这个系统当中使用的时候，会不会出现兼容性的问题？那么包括将来向上兼容的情况。谢谢。
I hear a friend told me that for the Dante 6 or above products, sometimes there's a compatibility issue. I kind of found that article, but I just heard it from a friend who told me. And I wonder, for the Dante 7 category or above, would we have a compatibility issue in the future?
I'm sorry, I haven't heard.
Compatibility.
I haven't heard of a version 6 or a version 7. Yeah.
7.
Sorry?
7 or 5 upgrade to the capability in Dante.
Sorry?
He said that someone told him about a report. Dante cannot capability with like over class 6. There's a class 7 category 7 cable.
Oh, we're talking about cabling standards. Oh, okay. No, that's that's not dictated by Dante at all. So if you want to come to our training session tomorrow for level 3, we go into some detail about how layered networking models work. So the factor with category 6 or category 7 cable is basically dictated by the electronics of the network port. So this laptop will have a network interface on it, and the physical driver circuit will determine whether it can use category 6 or category 7 cable. Similarly, when we make products, manufacturers take one of a family of switch chips which have that physical driver circuitry in it. So it really depends upon which piece of silicon was purchased by the manufacturer to build that. So that will need to be checked on a manufacturer by manufacturer basis. It's nothing to do with Dante. Dante sits above all that stuff in the data layers of the network. We don't get involved in the physical transmission layers, which is what the standards you're referring to are concerned with. Lovely. Okay. Well, thank you very much for coming along. Cheers.